Hi students, how we doing today? Oh, I'm doing great too. Thanks for asking. Okay, so this video is going to cover some important concepts. It's going to cover the 1.5 IQR rule along with the 5-number summary. Also, if you've been struggling with the tables to find the standard deviation, this video is going to help. And we're also going to get into z-scores a little bit. So I try to cover some ground here on this problem. So I call these try-along videos, and the idea is that one way, a great way to study is I'm going to read the problem right now. There's going to be 5 parts of it, parts A through E, and I recommend that you try it on your own. And then I recommend that you pause the video, try it on your own, and then I'm going to solve each individual part of the problem and kind of work the way through it. So let's waddle our way through this problem. Did you catch that? I quack myself up. Alright, ducks at Round Pond. A biologist counts the number of ducks at Round Pond at the same time for a period of 15 days. So these are the results down here, the dot plot. So we have the number of ducks, and we see clearly we have a range from 7 to 14, and it looks like the mode of the distribution is 8. So here's what we're going to do. We're going to A, find the 5-number summary, B, use the 1.5 IQR rule to identify any outliers, C, make a box plot. We're going to include we're going to include outliers on our box plot. D, we're going to calculate x bar, the mean, and s sub x, the standard deviation. In part E, we're going to find the z-score for the day with 14 ducks, and we're going to interpret what that z-score means using our results from part D. Two things. Why don't you pause the video right here, maybe write down these parts of the problem, and I'm going to scroll back to the, actually I'm going to scroll forward because I copied and pasted this one here. Here's our results, so see if you could try parts A through E. Again, finding all that. Okay, now that you're back, you never left. Okay, you did leave. Oh, good job, good job. Cool, what'd you get for A? Well, let's find out. Part A was, again, to find the 5-number summary. And dot plots is a nice little way of doing this, just counting the dots. So we were given that n was 15. That was given, and we can confirm that. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 dots. So step 1 of finding the 5-number summary is let's find the median. So the median, let's recall, this is going to be the position. The position of the median is n plus 1 over 2. So in that case, n being 15, that's going to give us 16 over 2, or 8. So it's going to be in the 8th spot. The easiest way to do this is count the dots. We're going to find the 8th dot. 1, 2, 3, 6, 7, 8. So the dot I circled right there is going to be the 8th dot. So we know the median is, the actual median is 9. And what happened here when we found the median, we should have split the data into 7 parts. That is, there's 7 dots less than this median right here, and there's 7 dots greater than. And just realize when I started counting up. So that means that that I'm going to start counting up from here, for instance, when I find Q3. So Q1 is going to be, now we have 7 dots here, right? 1, 2, 3, 4, 5, 6, 7. So using this same n plus 1 formula, 7 plus 1 is 8. 8 divided by 2 is 4. The Q1 should be in our 8th spot. Sorry, 4th spot. 1, 2, 3, 4. There's our Q1 right there, and our Q1 is 8. And we're going to do the same exact spot number of Q3 now. 1, 2, 3, 4. So Q3 is 10. So our 5-number summary, the minimum is clearly 7, Q1 is 8, the median is 9, 10 is Q3, and lastly 14 is going to be our maximum. Clearly we could see how all these numbers are 1 unit apart there. That's kind of telling us there's not a ton of spread. Not a ton of spread at all, but 14 is a little suspicious. It looks like it could be an outlier, doesn't it? Well, let's try. So part B asks us to use that. Let's make sure. Yeah. Part B asks us to use that 1.5 IQR rule to identify any outliers. And let's start out with what is the IQR. IQR, again, is always going to be our value of Q3 minus Q1. Q3 we had calculated was 10. Q1 we calculated was 8. So our IQR is 2. So any point now is going to be a low outlier. Let's check for low outliers. And it's going to be a low outlier if it's less than 1.5. Sorry, if it's less than Q1 minus 1.5 times the IQR. So what we want to do is calculate what this number is. Q1 we were given was 8. The IQR we just solved for was 2. 1.5 times 2 is 3. So 5. What does this number 5 mean? This means that any point under 5, or in this case any days when they observe less than 5 ducks, well, that's going to be an outlier. And clearly there was no values in this case less than 7, no number of days. Sorry, yeah, there's no values less than 7, hence no values less than 5. So there's no low outliers. Okay, let's check for high outliers. It's going to be a high outlier if it's going to be any point in there is greater than Q3 plus 1.5 times the IQR. We've calculated Q3 was 10. IQR didn't change from the last problem. In fact, what I add, remember before I subtracted, in this case 3 to Q1, I'm going to now add 3 to Q3. That's going to be 13. Any days that we had we observed more than 13 ducks at Round Pond? Indeed, right? We had a 14 in there. So we get now that since 14 is greater than 13, 14 is an outlier. So we do have one outlier in this case, as we kind of suspected. Again, just going back to this dot plot, we look at that and we go, yeah, 14, you know, that's not terribly far away from a majority of the data. So why is 14 an outlier? Well, it's partially because look at that tiny spread, 7, 8, 9, 10. Nearly all of our observations were in that range, except for the 11 and the 14. So even though 14, you know, it's just, you know, 4 extra ducks, 3 extra ducks, more than the other top selling or top duck counting day, it's far enough because there wasn't a lot of spread in our observations. So 14 is a high outlier. So let's make our box plot now in part C. So remember how to make our box plots. Start out with an x-axis, and our x-axis is going to be in the same units as whatever our variable is, and our variable in this case is the number of ducks at Round Pond. So let's label that before we do anything. Number of ducks, and we may as well give it a little title here. Let's call it Round Pond. So we start with our minimum, which was 7. I should actually mention, maybe first we should start with our outlier. Let's recall outliers on a box plot get these dots. So we'll get back to that outlier in just a second. But we had our minimum was 7, which was not an outlier. Our Q1 was 8, not an outlier. Median's never going to be an outlier, nor is Q3. So here's our interquartile. Now this whisker is going to stop here at 11. Why? Because 11 was our last observation, this guy right there, that was not an outlier. And then here, this dot right there represents our outlier right there. And this is our box plot. Okay, part D asked us to calculate the mean and standard deviation. Now for the test, I will give you this table, and it'll look like this. It'll have an x, it'll have an f, it'll have an f times x, it'll have an x minus x bar, and then lastly it's going to have an f times x minus x bar quantity squared. And it'll look like, and then like that one, maybe a little longer, it'll look something like this, and you got to fill in the rest. So yeah, I taught you guys how to do this on your calculator, and you could find it easily, but I want to see that you can perform this algorithm and do this by hand. So what goes in X, it's our observations, 7, 8, 9, 10, 11, and 14. That was the number, that's our variable, the number of days, number of ducks at Round Pond. F is going to be the frequency, and I'm doing this from memory. I'll double check in just a second, but I had two days that we had 7 ducks. I believe it was 5. I need to go back and look at the dot plot. Yeah, 5 days of 8, 4. Okay, I got it. 4 days of 9, 2 days of 10, and 1 day of 14. Sorry, let me go back and just double check. Got it. Okay, next thing I'm going to do is I'm just going to multiply the two columns together. So in other words, we're going to use this to find the sum of x, this column. But since, for instance, there were 2 days of 7, that means we're going to have, when we calculate, we're going to have 2 times 7, 14, 8 times. Okay, I'm just going to fill out these numbers here. I'm multiplying as I go down. Again, I'm sorry, as I go across, I'm multiplying across as I go down. And now I'm going to add all these up. I got a 5 here, carry a 1, so that's 6, 9, 11, 12, 13, 135. So what am I going to do with this? This number right here is actually going to be my total sum of all the x's. Now technically it's the sum of the frequency times x, but there's 2 ways to calculate the mean. That was either we said it's the sum of all the x divided by the sample size, or in our case what we're using is the sum of all the x times the number of times that you saw it times the frequency. These formulas look a little confusing, but again, this sum of x, either way we did it, we got 135. We said there were 15, and if I divide 135 by 15, I get 9. So on average, there were 9 ducks there at Round Pond. Okay, I'm going to erase all this I wrote in blue down here because I want to use this column again. Sorry, I want to use this space here. Go away. Okay. Alright, so the next column is going to be our deviation, x minus x bar, and we're only doing this now once because we're going to add in the frequencies in the second column. So we had we do need to write that down. We had x bar, we got our mean average number of ducks per day was 9. And when I do this, x minus x bar, I'm just taking my value of x, which was 9, minus the mean. It's going to be -2. In other words, 7 is -2 away from the mean. And in fact, 8 is -1. 9 is the mean, so it's 0. 10 is 1 above the mean. 11 is 2 above the mean. And then 14 was a whole 5 days above the mean. We don't need to add this column together, but if we do, actually, no, we don't need to add it. Don't add them up. It should equal 0, but the reason why it doesn't equal 0 right now is because we didn't account for the frequencies. We'd have to multiply it by the frequency, how many times of each day, and then it should add up to 0. But we don't need to do that. Okay, our next column is going to be the frequency times x minus x bar squared, and I know this looks scary, but this x minus x bar squared is simply the number that we got here, in fact the -2. So what we're going to do is we're going to take the frequency, which was 2, and times it by -2 squared, and 2 squared was 4, so 2 times 4 is 8. In here, next one, we had the frequency of 5 times -1 squared, which is just 5. Everything should be positive. Really easy. Once we have a 0, that's just going to be 0. 0 times anything is 0. And here we had 2 tens, which had a deviation of 1. So it's going to give us 2. Here we had 111. Had a deviation of 2, so it's going to be 4. And lastly, 14, we had a deviation of 5. There's only one of these, so it looks like this is going to be the biggest contributor to our standard deviation, and clearly why, because it was the furthest away from the mean. So now I can add all these together. 8 plus 5 plus 2 is 15. 19 plus 25 is going to give us 44. Okay, this value here, you did all the hard work to get this number. When we look at that, the general formula for the standard deviation, that it's the square root of n minus 1 times the sum of x minus x bar squared. That number we just got, the number 44, is the scary part of the equation. It's adding up all the deviations minus the mean squared. In that case, this number is 44. So the standard deviation now here, watch how easy this is going to be once we get this number of 44. It's going to be 44 minus n minus, divided by n minus 1, which is 14 in this case. So the square root of 44 over 14, I'm going to pause it and put in the calculator, which I got as 1.7, we'll round it just to 2 decimal places, 1.77. And that's our standard deviation. And if I were to ask to interpret what this standard deviation means, it means on average, if we look at all the number of round ducks observed over the course of these days, on average, the number of ducks varied about, the average number of ducks was about 1.77 number of days away from the mean. So it's about the average distance of all of our data points from the mean. And let's not forget too the relationship, this is the standard deviation. If I were to ask for the variance, hypothetically speaking, my handwriting's getting bad. The variance here is going to be s sub x squared, so it's just that same number, 1.77 squared. And again, if I put that on the calculator, I should have approximately my favorite number, about 3.14. Whew. 3.14, okay, 28. Pretty close to pi. Huh. And this 1.77 is just about my favorite number. It's the square root of pi. Only a math dork like me would care about something like that. Okay, so the last question here on this problem, going all the way back to all the work that I've done, was E. What is the z-score for the day with 14 ducks? And interpret this. So part E, the z-score, let's remember, is always going to be the data point minus the mean divided by the standard deviation. And we learned that there's 2 ways to represent the mean and the standard deviation, depending on if I'm talking about a sample or the population. We'll consider this a sample of 14 or 15 days out of, thousands and thousands of days that round pond has some ducks. So this is going to be 14, which was our observed number of days. The mean was 9 exactly, and our standard deviation was 1.77. Divide all those, I got 2.82. Again, we'll round these to 2 decimal places. So what does this mean? That on this day, we'll say this day is 2.82 standard deviations above or greater than the mean. And that's it. Smashing little problem. Video stayed under 20 minutes. It's not bad for me. I have a tendency to talk too much. My black cat's been in front of me nearly this whole time, getting in my way like he always does. But I hope this helped everybody, and happy studying.